The topic is state elimination techniques in theory of computation. It converts a given finite automata into an equivalent regular expression. In state elimination, we remove intermediate states of an automata and update the transition between the remaining states. Here, three types of models are used in the state elimination method, which are automata with 3 state, automata with 2 state, and automata with a single state. Coming to the first rule, automata with 3 state. The rule says in this transition diagram we have start state, final state and intermediate state. We have to eliminate intermediate state, choose one state and eliminate it, not the start state or final state. Replace the eliminated state by updating the transition between the remaining state with a new regular expression. In this transition diagram, we have 3 states: start state Q base I, final state P base J, at least one intermediate state, that is capital S, that needs to be eliminated. So given transition diagram, what are the steps to eliminate state? Choose an intermediate state to eliminate. Identify state capital S as the intermediate state that connects the start state and final state. Using the formula, we will get a regular expression equal to Rij plus Q base I S raised to the power star P base J. Next, an automata with 2 state. In this transition diagram, we have start state and final state. There is a direct conversion. If the automata has only the start state and final state, combine all paths from start state to final state into a single regular expression. Here there are no intermediate states and the task is to combine all paths from start state to final state. Using the formula, we'll get a regular expression equal to bracket of R plus SU raised to the power star T closed bracket raised to the power star SU raised to the power star. And last one, automata with a single state. The rule says self loop. If the automata has only one state, which is both the start state and final state, the regular expression is simply the closure of the transition on this state. Here the state may have self loop, which represent repeated inputs. Coming to the first problem, find the regular expression from the following deterministic finite automata. The given transition diagram consists of capital A start state, capital C and capital D are final state. Take the final state which comes first, capital B, the intermediate state to be eliminated. In step 1, apply the first rule for eliminating the intermediate state. To simplify the automata, we need to eliminate the intermediate state capital B. The possible path involving capital B are A, B, C, C, B, A. Draw a transition diagram of these two possibilities as given in the rules. Take the first two possibilities A, B, C. The given transition diagram, A is the starting state, B is the state to be eliminated, and finally C is the final state. Look at the transition diagram. The transition from A to B is labeled as 1. Here you write A to B is 1. There is no transition from A to C, so it is labeled as null. Here you write A to C null. Capital B has no self loop, so the transition B to B is also labeled as null. Here you write null. The transition from B to C include 0, 1, represented as 0, 1. Using the transition formula is applied to compute the updated path from A to C. After eliminating capital B, substitute the given values. We know that Rij equal to null. So Rij value would be null. Here you write null. Q base I equal to 1. So Qi value is 1. And next, capital S is to be eliminated. So capital S having the self loop null. Here you write S equal to null. And last one, P base J value would be 0, 1. 0, 1 represented as 0 plus 1. Substituting these values into the formula Rij plus Qi s raised to the power star Pj. Here Rij value null, Qi value 1, s value would be null, P base j equal to 0 plus 1. Then here you substitute the values Rij null plus Qi value 1, s value null raised to the power star. Then finally P base j would be 0 plus 1. Now simplifying the equation, here null star, as we know that null star means epsilon, here you write epsilon. So null plus 1 epsilon 0 plus 1. We know the formula epsilon r equal to r, which means epsilon 0 plus 1 is 0 plus 1. Here you write null plus 1 of 0 plus 1. When you add with the null, you will get a result in the regular expression 1 of 0 plus 1. We done the first possibility. The next possible path is CBA. Draw the transition diagram for the given path. The transition from C to A, C to B, B to A and B to B, this is null because there is no input for all transition. Only capital A as self flow. Transition on capital A to A is 0, 1. Here you write 0, 1. The transition formula is applied to compute the updated path from C to A. After eliminating capital B, substituting the given values Rij null, Q base I null, S value would be null, Pj value null. Finally, the resulting regular expression is null. So the first possibility, the regular expression is 1 of 0 plus 1. Second possibility is null. Therefore, the deterministic finite automata after eliminating capital B is represents the simplified path from A to C after eliminating the intermediate state capital B. The transition from A to C is 1 of 0 plus 1. C to A, after eliminating the intermediate state capital B, we get null. Leave it alone. Take the capital C and capital D state as given in the reset of original transition diagram. With this answer, that is this transition diagram, we can proceed to the second step. In this transition diagram, A is our starting state, D is our final state, C is the state to be eliminated. To simplify the automata, we need to eliminate the intermediate state capital C. The possible path are ACD, DCA. Draw the transition diagram of these two possibilities as given in the rule. Take the first possibility and apply the first rule for eliminating the intermediate state ACD. According to the given diagram, capital A is the starting state, capital C is the state to be eliminated, and capital D is the final state. The transition from A to C is 1 of 0 plus 1. Here you write A to C 1 of 0 plus 1. Next, A to D. A to D, there is no transition, then labeled as null. A to D labeled as null. Next, C to D. Look at the transition diagram. C to D, there is a transition 0 plus 1. Here you write 0 plus 1. Next, C having a self loop. Here C has no self loop, so the transition on C to C is labeled as null. Here you write null. Using the formula updated path from A to D after eliminating capital C, substituting these values Rij is null, Q base I is 1 of 0 plus 1, S value would be null, and finally P base J value would be 0 plus 1. Substituting these values into the formula Rij value null plus Qi value 1 of 0 plus 1, S value would be null raised to the power star, Pj is 0 plus 1. Simplify the equation null star epsilon. Here you write epsilon. So null plus 1 of 0 plus 1, epsilon 0 plus 1. Epsilon r. We know the formula epsilon r equal to r, which means epsilon 0 plus 1 is 0 plus 1. and finally you will get a null plus 1 of 0 plus 1, 0 plus 1. When you add with null, you will get a result in the regular expression 1 of 0 plus 1, 0 plus 1. We done the first possible path. Next possible path is DCA. Draw the transition diagram for the given path DCA. The transition from D to A, D to C, C to A and C to C, this is null because there is no input for all transition. Only capital A as self-loop transition on A to A is 0, 1. Look at the transition diagram. In this transition diagram, D to A, there is no transition. D to C, no transition. C to A, there is no transition. And C to C, no transition. This is null. That's why we put a null to all the transition. Finally, you substitute these values into the formula, you will get null. Therefore, the deterministic finite automata after eliminating capital C is, look at the previous step, the path from A to D after eliminating the intermediate state capital C, we got the regular expression 1 of 0 plus 1 of 0 plus 1. So, the transition for A to D is 1 of 0 plus 1, 0 plus 1. Here you write the regular expression. A to D is 1 of 0 plus 1, 0 plus 1. Next possible path is DCA. D to capital A, after eliminating the intermediate state capital C, we get null. Leave it alone. Then A as a self loop 0 plus 1. Look at the original transition diagram. A is having a self loop 0 plus 1. So here we written 0 plus 1. So finally, there is a transition from A to D is 1 of 0 plus 1, 0 plus 1. A is having a self loop 0 plus 1. In this transition diagram, there is a starting state capital A and the final state would be capital D. We cannot simplify it any further. It has exactly one start state and one final state. So we need to find the regular expression for this using the second rule. Coming to step 3, find the regular expression for two-state automata. With the updated transition diagram, we can now proceed to the third step using the formula regular expression equal to bracket of R plus SU star T raised to the power star SU star. By substituting these values into the formula, you will get a resulting in the regular expression. Here R value would be 0 plus 1, S value is 1 of 0 plus 1, 0 plus 1, U value going to be null and T value would be null because there is no transition from D to A. D has no self loop, so the transition on D to D is labeled as null. D to A, there is no transition, then here you put null. Apply the values into the formula. R value would be 0 plus 1 plus S value 1 of 0 plus 1, 0 plus 1. U value null raised to the power star. T value would be null. And finally you put raised to the power star. And S value again 1 of 0 plus 1, 0 plus 1. U value going to be null raised to the power star. On simplifying the equation, 1 of 0 plus 1, 0 plus 1 null star null. If you multiply with null, you will get null here. Then the entire line going to be null. So 0 plus 1 plus null raised to the power star. 1 of 0 plus 1, 0 plus 1 null star. Null star means epsilon. Here you write epsilon. When you multiply epsilon with regular expression, you will get the regular expression 1 of 0 plus 1, 0 plus 1. Finally, you will get 0 plus 1 raised to the power star, 1 of 0 plus 1, 0 plus 1. Using the state elimination technique, we converted a finite automata into an equivalent regular expression. If you have any questions or need further clarification, feel free to leave the comments in the comment box. Thank you.